I'm Alana Maya with Water World Magazine. Today, my special guest is Gerhard Forstner with Centrisys CNP. Thank you so much for taking the time to speak with us today.
Thank you very much, Elena. Glad to be here.
So I wanted to talk to you today about phosphorus recovery and getting the most out of your nutrient recovery process. Can you talk to me about some of the processes with Centrisys? I know MagPrex is a new name, and is that different from the AirPrex process?
Yes. Let's talk about MagPrex first. So initially, the product was known, the technology was known under the name AirPrex. At the time when we started this process in 2014 or so, we had a partnership with a German company, CNP, and hence the name is owned by this company. Hence, we use the same name in America. Throughout these years when we've built these first processes, the technology has evolved, has developed any further, and now we have come to this conclusion that it would be better to operate independently, so separate as companies, and therefore we came up with a new name, which is MagPrex. The MagPrex technology is based on the old AirPrex technology with the proven installations with certain improvements, but it was important for us to be on our own here in the United States. We're based here in the United States, in Wisconsin, so to operate independently in order to be more agile to the needs of the US customer base. You know, for an example, at the first installations, we imported these big tanks from Europe, from Germany, right, with a boat. So there were high costs in shipping, and it really didn't add much value to our customers. So now everything is sourced in the United States. And therefore, we said, okay, we had to come up with a new name and let's build on our strength here in the US, what we can offer in order to provide really a better product and more economical product. And so that's the MagPrex is what used to be known with the AirPrex with some improvements.
And in addition to MagPrex, you also offer CalPrex in your nutrient removal offerings. What is the difference between the two of those?
Yes, that's correct. So we have two processes. MagPrex is a process which removes the phosphorus from the digested sludge, so after an anaerobic digester. And the product recovered is called struvite. And CalPrex is a process which recovers the phosphorus prior to anaerobic digestion. So the big difference is and the product recovered with CalPrex is called brushite. That's a dicalcium phosphate. So with MagPrex, you need an anaerobic digester. So we are limited to the opportunities where you have to have a plant with some form of anaerobic digestion plant, and then you go after that and recover the product. With CalPrex, we can go in front. We can recover phosphorus in any plant, and that also industrial applications now where there is no anaerobic digester. So CalPrex uses a fermentation process. What usually happens in an anaerobic digester to solubilize the phosphorus, make it recoverable. And then CalPrex with those calcium hydroxide to provide the calcium and the pH change to bind the phosphorus with the calcium, and it comes out as calcium phosphate. So you have more phosphorus content with CalPrex, and you have a better recovery rate, and you recover the phosphorus. If there is an anaerobic digester, you recover it before the anaerobic digester.
Would there be a reason for a plant to have both of those processes for nutrient removal kind of occurring simultaneously?
Yes, the big advantage, what we have proven is for MagPrex is the extreme high efficiency in removing orthophosphate. So we can go down to very low effluent concentrations without overdosing on magnesium. CalPrex is very, very good at large phosphorus quantities, but it's harder to go to a lower limit. So if somebody says I have high incoming concentrations, but I need also the very, very low limit on the end, what can be done is to recover first with CalPrex the majority of the phosphorus in form of dicalcium phosphate or brushite, and then after the anaerobic digester, for example, you can have AirPrex to go down to a very low effluent limit of orthophosphate.
What's the difference between struvite and brush-type fertilizers?
So struvite magnesium ammonium phosphate, it has about 12% phosphorus in content in it as a fertilizer. Brushite has 18% phosphorus in it. So right there, the economical value of brushite is much higher than that of struvite. Brushite does not have ammonium in it. Struvite does. Hence, also, brushite can be much easier dried, pelletized, because you don't have to consider yourself going about certain temperature. Versus with struvite, once you heat it up about a certain temperature, the material changes. You lose the nitrogen, the ammonia, and it's not as valuable. So from a fertilizer value, the brushite is more valuable than struvite.
And then finally, in your opinion, what would be the biggest advantages for plants to use these nutrient recovery systems?
Most plants, when we look from an economic standpoint of view, phosphorus recovery allows any plant to improve the devourability of the digested sludge, meaning that if you recover phosphorus with a technology, a plant can achieve higher cake solids, meaning they have less biosolids to dispose of. So that's the biggest really economic saver for any mid-sized or larger plant, to get better devourability, get better drier cake solids. The next one is the reduction of recycle loads of phosphorus going back to the front of the plant. So we remove about 90% of that phosphorus going back to the plant. And then finally, which is a big deal to many plants as well, is the maintenance avoidance or reduction. With Calbrex, for example, we would have significant maintenance reduction even in anaerobic digester, because you don't have struvite or brushite forming in a digester when we divert the product before the digester. With air brakes, we would have definitely after the air brakes, after the digester, before the dewatering equipment and the pipes, to really mitigate any nuisance by struvite formation in the pipes. It doesn't happen anymore because we have removed the source, which is a phosphorus from happening. If you talk to the plants, to the operators, for them, maintenance will be really a nuisance and will be big, maybe the biggest factor, but strictly from a cost perspective, it's really the improvement in devourability, because phosphorus holds water. Once we remove the phosphorus, we can increase the dewater content of these digested biosolids.
Well, great. Thank you for taking the time to speak with me today, Gerhard. If people are interested in learning more, where can they go to get some more information?
The best place would be our website. A lot of information is listed on our website. We have case studies, we have contact information. I also would like to point out we do have our pilot testing capabilities for both technologies. So we have a full-scale pilot for Macbrex, and we have a full-scale pilot for Calbrex. And if anyone is interested in testing in their plant, we would be happy to contact them and provide more information on our pilot testing capabilities.
Well, thank you so much again for taking the time to speak with me today. I really appreciate it.
Thank you very much, Elena. It was my pleasure. Thank you.
For Water World Magazine, I'm Alana Maya.